really similar, so I'm going to fly through this one. For the general term formula, I need u1, which in this case is 5, and I need d, which I can recognize as negative 11, subtract negative 3, for example, which is negative 11 plus 3, negative 8. So I'm going down by 8 each time, so my common difference is negative 8. And the general term formula is going to be un equals u1, 5, plus n minus 1 times d, which is negative 8. Distributing that negative 8 in there, cleaning things up a little bit, I end up with 5, subtract 8n plus 8, so negative 8n plus 13 is my general term formula. I can use that general term formula to find the value of the 12th term. So I'm looking for u12, and I have n equals 12. So I'm plugging those values in to my general term formula. I end up with u12 equals negative 8 times 12 plus 13. I end up with negative 96, 8 times 12, plus 13, which gives me negative 83. So the value of my 12th term is going to be negative 83. Now I need to find the term number for negative 107. So I know that un equals negative 107. I've got to find my n value. So solving for n here, subtracting 13 from both sides, I end up with negative 120 equals negative 8n. Dividing both sides by negative 8, I end up with n equals 15. So 107 is the 15th term in this sequence. And then finally, it's asking me whether or not negative 67 is a term in the sequence. So I set my sequence equal to negative 67, and I solve for n to see if n is going to be an integer. So again, I'm subtracting 13 from both sides. Negative 67 minus 13 is going to give me negative 80. And dividing both sides by negative 8 gives me 10 equals n. So negative 67 is going to be the 10th term in this sequence. Therefore, yes, negative 67 is a term in the sequence. Finally, we've got these K questions, and these are pretty common on your IB assessments. So we'll solve one together today. It says, find K given the consecutive arithmetic terms 2K plus 7, this is all one term, 3K plus 5, and 5K subtract 4. So these are consecutive terms. What that means, consecutive, means one after another. The clue that we're given here is that this is an arithmetic sequence, which means it has a common difference. And you'll remember earlier we talked about finding the common difference by taking one term and subtracting the term before it. And that gives you your common difference. So for example, we could find our common difference here by taking 3K plus 5 and subtracting the term before it from that. So we could subtract 2K plus 7. And that would give us our common difference. So let's work that out a little bit. Distribute this negative here. We end up with 3K plus 5 minus 2K, subtract 7. We've got some like terms there. 3K minus 2K gives me K, and 5 minus 7 gives me negative 2. So there's one formula for my common difference, but you'll notice that I have two unknowns in this formula. I have a K and a d, which means I can't solve it as it is. So I'm going to have to find another equation so I can use a system of equations to solve it. The other way I can find my common difference is by taking my third term here and subtracting from it my second term. So I can take 5k minus 4, subtract 3k plus 5. That's also going to give me my common difference. And you'll remember the whole point of a common difference is that it's the same between every set of terms that you have in a sequence. So if I solve for this common difference, it's going to give me the same value as the common difference formula that I just found right here. So let's take a look at that. So simplifying here, I end up with 2k subtract 9. So I have two formulas for my common difference, and these common differences are equal to each other, which means that k plus 2 also has to be equal to 2k minus 9. So we're going to set those equal to each other over here. K minus 2 equals 2k minus 9. From there, we can solve for k. So I might choose to subtract k from this side and from this side and add 9 to both sides. Negative 2 plus 9 gives me 7. 2k subtract k gives me k. And I end up with k equals 7. With these questions that are a little bit more complicated, it's always best to check your work. So if k equals 7, my first term here, 2k plus 7, would be 2 times 7 plus 7. So 2 times 7 is 14, plus another 7 is going to give you 21. I can do the same thing for my second term. 3 times 7 is 21, plus 5 gives me 26. And then finally I've got 5 times 7, 35, subtract 4 gives me 31. And you can see for this sequence that these are consecutive arithmetic terms because I have a common difference of 5. So that tells me that I've done the calculations correctly.